If you want to create a peptide or protein chain in CcpNmr analysis which contains a non-canonical amino acid, you will need a so-called ChemComp file which describes the topology of that amino acid. Now there's a collection of should we say standard non-canonical amino acids which you can access. It's on the FaustaLab GitHub page at github.com/FaustaLab, and then simply go to CcpNmr ChemComps, then here to Data, ChemComp, and Protein. And here you'll find a long list of thousands of amino acid template files. But you may of course be working with something more bespoke, and in that case you'd want to be able to create your own ChemComp file, and I'm going to show you how you can do that using the program ChemBuild. Now ChemBuild is a program that comes with CcpNmr analysis, so in your bin or your bat folder where all of your executable files are, you will see that as well as the standard executables to open analysis, assign, metabolomics, screen and structure, there's also this one, ChemBuild. So simply double click that or do it from the command line. This is what ChemBuild looks like. It's not dissimilar to standard chemical drawing programs, but it does have a number of NMR and CcpN specific elements to it as well. Now to create your template file, you will need to start with, here in the amino acid section, a so-called linked template. Simply drag that onto your canvas, and you can see this is the basics of an amino acid, and you could then modify it in whatever way you need. Now we're going to go to this tab here called Compound Variants, and you'll see that there are a number of different variants of this amino acid available. Some of them are labelled free, so that's just the free amino acid, and it's available in different protonation states. But we also have variants depending on where the amino acid might be in a peptide chain. So it could be at the start, in which case it would be linked to another amino acid here from the carbonyl carbon. It could be in the middle, in which case it would have links on both sides, both through the carbonyl carbon and the nitrogen, or it might be an end variant. And again, you've got different protonation states available. I would always recommend that you go to the middle variant as you create your template file, because that way you know exactly where these links are and you won't accidentally delete them. That's particularly important if you wanted to create an additional link here, removing this proton and adding some kind of additional set of atoms there. Now you can just add to your side chain or take away from it, so I can just click on this atom that selects it. You can remove an atom using this icon up here. I can drag on a new carbon. Bringing two black dots together makes them green and forms a bond. I can also bring on an additional carbon just with the keyboard by typing C. If I've got one carbon already highlighted, it will just add it onto there. If nothing is selected, it will just add it into space. You can also get templates here from the side, so for instance you could get a ring and add that on as well. You can highlight everything either by dragging the mouse over it, or you could also use Control A, or on a Mac it would be Command A. This little icon here will add hydrogens onto all the remaining valency sites of your carbons. If you select everything and go for this little icon up here, it will just rejiggle the molecule a little bit so that nothing is overlapping. Now you can see here a little blue line connecting these two hydrogen atoms. That's to show that they are prochiral, and the same over here. We've got red lines connecting these hydrogen atoms in the methyl group to show that they are magnetically equivalent. Now we're going to have to do something similar here on this ring, because of course through ring flipping these elements will also be equivalent. So I'm simply going to select both of these by holding down the Control or Command button as I select them, and then go back here to Atom Properties and say Set Equivalence. and the same for these two, and then I need to repeat that for the hydrogen atoms as well. And then finally you can also change the labels. So you can see that the linked template I started with starts with the CA/CB labelling. Everything else is simply labelled with numbers. I'm now going to change that to follow the standard C-gamma, C-delta, etc. labelling. Simply double click on a label and type in something new, and off we go. Okay, I finished relabeling everything. Now, before we export our file, I just want to draw your attention to the fact that you don't have to create your molecule completely from scratch. You can also import files using a number of different file formats, so that if you've got something like that, you could import it and then attach it to this linked template. Once you're done, we need to export, but we first go to our compound info section, because here we can give our molecule a name. We can give it a CcpN code. You can either use the code, random code generated provided, or you can use a 3-letter code, but you have to make sure that it doesn't clash with one of the ones provided in that long list I showed you just now on GitHub. And finally, we need to say that this is a protein type. Now we can go to export and choose CcpN ChemComp XML file. That's all saved, and we're done.